Today's lesson is going to be over graphs of proportional relationships.
Oh my God.
All right, I'm going to talk to you a little bit about the coordinate plane. I'm hoping that this lesson is going to be a bit of a review for you. If you would, take out your red pen, and we're going to label the x-axis. This right here will always be the x-axis. Guess what the other one going up and down is going to be?
Y.
The y-axis is correct. Okay, so let's label those with our red pens. Another thing that I want to make sure that you always know, an ordered pair will be written like this. The x will come first and the y will come second. So if you would, go ahead and circle that. There's one thing that I want you to know. If you would put a dot right there where the x and the y-axis intersect each other, let's put a little arrow. This is what we would call the origin. Now, an origin is like the beginning, okay? So for us, the origin is always going to be at 0, 0. So please write that in with your red pen. All right, now with your pencil, what we're going to do is we are going to label these lines, okay? So going to the right, it'll be 1, 2, 3, 4, 5. Here's what I want you to notice. I am labeling the line. Okay, do this with your pencil. I am not labeling the box. This would be called labeling the box, okay? But I don't want to label the box. Instead, I want to label the line. So please make sure yours does not look like that in the box. On the x-axis going to the left, guess what this line would be? -1. Keep going in a negative direction. It's just like a number line. Now I'm going to label the lines going up. This is the first line, second, third, fourth, and fifth. And then going down, I want to see if you guys can discover what it is that I just did incorrectly. Raise your hand if you can see where I made the mistake. Jonathan, what did I do wrong? All right, if you look right here, I skipped the first line. That should have been my -1, okay? That's a big problem that I see a lot of people do, so be careful. I know it's squishy with a lot of stuff going on there, but that first line is going to be -1, and then you will go down in the negative direction. As we work on the coordinate plane, there's a few things I want you to know. Repeat after me. Start at the origin. Okay, then this will always be the x, and that's going to tell me to go left or right. If it says -5, should I go left or should I go right? Correct. So I'm going to go left here to the -5, and then you'll see this one right here is my y. That will always tell us to go up or down. Does a 6 say to go up or down? Up. Very good. All right, so technically I guess we should have come all the way up to 6. So we went left 5 and up 6. Then label that point A. Let's go to the next one. You can see over here point B says -2 and 4. Repeat after me. Start at the origin. Should I go left or right? Left, it says to go to -2, and then should I go up or down? Up, because it's a +4. So I'm going left 2 and up 4. Let's put our dot. And this is point B. All right, repeat after me. This next one's going to be 5 and 3. Say this with me. Start at the origin. Go left or right. Should I go left or should I go right? It says +5. Which way is +5? Right. Go to the right 5 and then go up or down. Should I go up or should I go down? I should go up how many?
5.
Look right here, guys. This tells me to go right 5 and up 3. What point am I going to label that?
3.
Point C. Very good. Let's go on to the next one. This one has tricked some people today. Everybody, put your finger on your paper at the origin. Repeat after me. Start at the origin. The first number is a 0. Should I go left or should I go right to get to 0? Don't go anywhere. Stay right there. So keep your finger there. Now go to the second number, number 2. That's my y. The y tells me to go up or down. If I'm going 2, should I go up or down? Up 2. All right, so you can see point D did land right there on the y-axis. Let's do our final one. I'd like you guys to plot point E on your own. All right, so with this one, I start at the origin. Guys, should I go left or right?
You should go right. Left.
Right, how many?
Right. Two.
Right, 2. And then where should I go?
Down.
Down how many?
6.
Very good. How many of you would say, which means I should go there? You got that same point that I did. And make sure you have labeled it point E. All right, for the next one, it says to tell whether or not these are proportional. When something is proportional, it just means that it is balanced. I'd like you to take out your red pen. We're going to label once again. This going left and right will always be the x-axis, and this going up and down will be the y-axis. Off to the side one more time. I want you to write it x and y, because that is what an ordered pair will look like. Now I'm going to take this right here, and I'm going to make this look like an ordered pair. The x is a 1, and the y is a -2. Who can tell me what I will write for this next one right here? Reagan, what will I write?
You'll do 2 and comma 0.
2 and 0, very good. Autumn, what will the next one be?
3 comma 2.
3 and 2. Jace, the final one. 4 and 4. Now we are going to label or plot those points on our graph. The first thing I want you to do every time is label the lines. Okay, let's just label up to 5 in each direction. All right, let's see if we can figure out how to plot the first points, 1 and -2. Repeat after me. Start at the origin. Go left or right. With this right here, am I going left or am I going right? Going right. How many? 1. Okay. Then go up or down. Which way am I going with a -2? Down. Very good. So I have to go right 1 and down 2. Put your dot. Let's go to the next one. 2 and 0. Repeat after me. Start at the origin. Go left or right? Which way? Right 2. Then go up or down. Where am I going? Nowhere. Why not, Abigail?
Because the origin is 0 and there is no 0 on the graph.
Okay, it tells me to move 0 spots. So that's why I'm not moving anywhere else. Let's go to the next one. Who wants to help me with the next one? Jonathan, what do I do?
Till you go up 3,
Okay.
and then you go left 2.
Okay, up 3 and left 2. Is this correct, class?
No.
Do this with me, class. Start at the origin. Go left or right.
Right.
Okay, this says right 3, then go up or down. What does that tell me? Up 2. Okay, so we are going right 3 and up 2. Next one, Nasir, what do I do?
You go right 4,
Right 4
and then up 4.
and up 4. You are correct. Now we are going to play a little bit of connect the dots. So if you would please connect the dots. How many of you played connect the dots as a little kid? It was such a happy time. So there you are. We are now connecting dots. Now here's what the question asked me on number 2. Tell whether x and y are proportional. I'm going to tell you the answer is no. And it asks me to explain my reasoning. Here's why. And this is something new I'm teaching you right now. If it doesn't pass through the origin, it is not proportional. So the answer is no. It doesn't pass through the origin. Guys, what was the origin? 0. 0, 0. As you can see, this right here is 0, 0. No matter what I did, even if this continued going down, it's not going to hit 0, 0. If this continued going up, it will never hit 0, 0. So that's why this graph is not proportional. Okay, the next one is going to be done basically the same exact way. Tonight on your homework, you will have a problem that looks just like this. So you will write the original problem, which is this graph right here, and then you will draw your own coordinate plane on your notebook paper. Okay, I also want you to label that coordinate plane. So go ahead and do that right now. As you're labeling, just remember you are labeling the line and not the box. Be careful not to skip lines. In this case, we'll just go 5 in each direction. All right, let's see what you guys came up with. The first one, should I go left or right? Left 1, and then up or down? Down how many? 2. Very good job. The next one's 0, 0, so we're putting it right there at the origin. MJ, where does the next one go? Okay, right how many?
2.
Right 2, and up how many?
1 2.
Very good. Right 1 and up 2. Then I'd like you guys to connect the dots. Class, is this proportional, yes or no? Yes, why? Correct. It passes, don't just say through the middle, I want you to say it passes through the origin. All right, go ahead and box in that answer for me. All right, the next one, we've got a graph here. Graphs can give us a lot of different information, okay? This graph shows the speed of a subway car. Raise your hand if you've ever ridden in a subway before. Is it above ground or below ground? Below ground, okay? So do they typically go pretty fast or pretty slow? Fast. They go very fast. So in this case, we are trying to figure out how much speed it goes in miles per minute. Take your red pen if you would, and I want you to circle where you see the X on this graph. The X is labeling the time, which is in minutes. Go ahead and underline the word minutes and draw a little arrow there, basically just telling us the X is helping us to see how many minutes this subway car has traveled. The Y, what is the Y measuring for us, class? The distance or the miles. Everybody underline that word miles. I know it's kind of on the side, and draw a little arrow telling us that the Y is representing the miles that it goes. Okay? So in this case, we are trying to figure out, find the speed in miles per minute. Down here at the bottom, do you guys see anywhere where it tells us 1 minute? Yes. If I look, it's right here. I've highlighted it. Now I want to go up. What distance does it say I have traveled at 1 minute? 1/2 what? 1/2 mile. So this is our answer. We are traveling at 1/2 of a mile per 1 minute. Does anybody remember what that's called when we have per something that's a 1? A unit rate. That was on our test yesterday, okay? Or there's another way that you could say this, and some people wrote this on their test too. 1/2 of a mile per minute. I do not care which way you write it, but I want you to just understand basically how to read a graph like this and what kind of information a graph like that can give to us. All right, there's some other important stuff that I want you to write down, so if you would take out your red pen and write this slide down, please. So this is the formula for constant of proportionality. It is y equals kx. Take your red pen and draw a cloud around this new formula, y equals kx. You can see my arrow is pointing to the k. Guys, what does that k stand for? What's it tell us it stands for? The unit rate. Very good. And then another idea I want you to make sure you understand is the graph of this line will always pass through the origin. And what points are the origin? 0, 0. Good job. Okay, so for this last problem, we've got modeling real life. It says the graph shows the area of y in square feet that a robotic vacuum cleans in X minutes. How many of you would say you have one of these robotic vacuums at your house? How many of you it's ever been stuck somewhere, like under the couch or things like that? Okay, well this one is hopefully going to be working well. We can see that it says the area of y, so take your red pen, circle that y, and what does it tell us that the y is representing? The square feet, okay, that it's covering. What does the x represent, class? The minutes, the time that it takes for that Roomba or that Shark vacuum to clean the house. Now, let's see if we can just identify some information that's here. Let's say that I'm wondering about or let's say a whole minute, just for easy sake. At a whole minute, go up to where it hits the hole. How many square feet has it cleaned at 1 whole minute? Very good. You can see it right there, 16 square feet. Let's keep going instead now, just to decide if we can read this. At 2 whole minutes, how many square feet does it say it has cleaned? 32. Now, this is what my question has asked me. Find the area cleaned in 10 minutes. Guys, does my graph go up to 10 minutes? No. Why do you think that this graph doesn't continue to go all the way to 10 minutes?
It would be very
It will be way too long. If we think about it, if this thing keeps going, it's going to keep going and going and going. And I cannot fit that huge graph on my paper. All right? So instead, that's why we have this constant of proportionality. I want you to write that new formula I gave to you, y equals kx. Does anyone remember what we said that k represents? The unit rate. I want you to write over that k with your red pen. The unit rate always has a denominator of 1. So if we are trying to figure out how many square feet per minute it travels, do we know by looking at our graph right here how many square feet it traveled in 1 minute? How many?
4.
Look at this. This is the 1 minute. If I come up here, what does it land on? 16. So my unit rate would be 16 square feet per minute. So instead of putting that k right there, I'm going to erase that and plug in a 16. Remember, the x right here represents the minutes. So if I plugged in 1 minute, remind me again, guys, what does it mean when there's a number next to a letter? Multiply. So if I plugged in a 1 right there, 16 times 1, how many square feet would it have traveled? 16. Let's say I plugged in a 2 right there. I would have to do 16 times 2. What's that? 32. But I don't care about 1 minute, and I don't care about 2 minutes. How many minutes is it asking me in my problem? 10. So instead, what will I plug in for my x?
10.
A 10. So this formula helps me to know, guys, how many square feet will I have traveled in 10 minutes?
160.
How'd you get that?
Multiplied 16 by 10.
All you did was multiplied 16 by 10 to figure out that it will be 160 square feet. Tonight's homework is just 8 problems on 5.5. You will need a graph on numbers 5, 6, and 7. So remember, on that graph, you're just going to kind of write it like this and label it because you don't have it on graph paper. You're just going to do it on notebook paper.